Ashland or the opposite side of Ashland?
Someone's in between Subway and Ashland.
One doing subway to opposite, okay.
Alright, first thing, survey. On the survey, it asks how old are you? Pretty easy, right?
Good.
Are you taking a foreign language? We talked about that a little the other day. Are you taking probability and statistics? That's sort of an obvious one, right? We'll talk about that here in a minute. Have you ever stolen anything?
What?
When I total all these up, a bunch of you gonna lie to me? Have you ever stolen anything from a friend?
Give it back.
You ever-
No.
Have you ever taken money from your mom or dad without asking?
Why'd you get personal?
Now, why did I get personal?
Creep.
So I'm a creep? Is that what you said?
Yeah.
On these, Malachi asked a question right before he turned his in. What he asked? Do you put your name on it? When you're looking at the one that I'm holding in my hand here, what do you not see here? It doesn't say, it doesn't have a blank for your name, right? Some of them did, some of them didn't. Why would I do that? When are you more likely to be more honest on something like this? When you don't have to put your name on it. And it used to be, I changed it up because of some of the events that have happened here in the last couple of years. Used to be I asked all kinds of questions about drug abuse and have you ever, controlled substances and stuff like that. And people, here, these, you might lie to me if you have to put your name on it. But when I had the stuff on there about controlled substances, most people would most definitely lie to me, right? You're not going to tell me that. You're not going to let me, especially in this small class. So what's that do to my survey? It ruins it, all right? Throws it off. And that's called a bias, all right? If there's some kind of bias that causes it not to really tell us exactly what it should tell us. We talked a little about this last week when we talked about the presidential election from last year and how Donald Trump right now has got like a... Yes? Did it not go through?
No.
Maybe I forgot to hit submit.
Okay.
Thank you.
Thank you.
Yeah.
But how the media is saying that he's got like a 30% approval rating right now, and it's the lowest that any president's ever had. Well, I sort of find it hard to believe that since he was elected, that his approval ratings went down that much. Not in no way, shape, or form am I a big fan of Donald Trump's, but that seems sort of biased to me somehow. The other one, if I did this survey, they're getting ready to fire me. So I'm doing this survey and I ask students, are you taking probability and statistics? Well, when I look at those papers, what percentage people surveyed are going to say they're taking probability and statistics? 100%. So then I turn in that, I say, look, I did a sample, did a survey, and 100% of students here at National Trail take probability and statistics. You can't fire me, I'm the only one that teaches it. Would that be biased? Yeah. All right. This is what we're going to go over today. Some of this stuff about surveys, different ways to do a survey, different things that could affect the survey. Back back to the homework. Questions. Can help Katie out here and do some of her homework for her.
So that means get ready.
She could be writing it down.
Seven.
Questions on the homework, page 13. It was page 13.
Yep.
Want me to run down through them again?
Yes.
Like last time, just to see if you got them right or wrong. It's not really fair. I think she can write that fast.
Yeah.
What did we end up doing? 7?
7, 6,
Number 7, qualitative. Again, I don't have I'm not gonna read them all the questions. Remember, qualitative means you're showing a what? Quality. Brown eyes. Shirt color, something like that. Number 8, quantity. Quantity, you're showing a what? Or quantitative, I should say. Some kind of number, a count. 6 males, 4 females. Male and female are the quality. The number, how many of them there are, is the quantity. Number 9, quantitative. Number 10, qualitative. If I come to one and you don't agree with me, we'll go back and read it and try to figure it out. I may have missed it. I don't remember. I don't even think I checked this homework. Number 11, quantitative. Number 12, quantitative. 13, qualitative. 14, qualitative. You all right so far? 15, quantitative. 16, qualitative. And this one? Which one? 15? 16? 16, you said or I said maybe I'm wrong.
No, I said.
Species of trees in a forest. If you're talking about the species, then it's qualitative, right? If we're talking about how many of each tree there is, quantitative. 17, qualitative. 18, quantitative. Then 19, what do they ask us to do on 19? Okay, so same thing, and then also tell the level it's at, right? Our 4 levels, are they still over there? Nominal, ordinal, interval, and ratio. Make sure on these you're asking, because again, I'm telling you, I mess up a lot on these. 19, qualitative and ordinal. Remember, with ordinal, with that measure of data, ordinal, you're doing what to it? First 3 letters sort of tell you.
Order.
Some kind of order. 20, qualitative and nominal. What's the thing you have to remember with nominal? You could almost say the first, it's always qualitative. You could almost use the first 3 letters here if we just change that 1 letter to an A. And remember that with nominal, it's given some kind of name. It's just given a name. At the nominal level, you're just given some kind of name, like National Trail, Tri-Village, Bradford. You're just naming the school. 21, qualitative and nominal again. 22, quantitative and ratio. Quantitative and ratio. Remember, with ratio, you can do all the math stuff with it. You can add, subtract, multiply, divide, and it still comes out to be a meaningful number. 23, qualitative and ordinal. Qualitative and ordinal. 24, quantitative and ratio. And then, 25, they start just asking us what the level was. 25, ordinal. 26, ratio. 27, nominal. 28, ratio. Anybody have any trouble with those four? Those are probably the hardest ones, right? You gotta, looks like, maybe I did grade this paper, because it looks like I missed 2 out of the 4 there. 29, it's got part A, B, C, and D. 29 is at the interval level, or I'm sorry, A is at the interval level, B is at the nominal level, C is at the ratio, and D is ordinal. So A interval, B nominal, C ratio, D ordinal. And 30, interval, B is nominal, C is interval, and D is ratio. How about those? Any better on those? Any of that make any sense, Camden, or you just probably couldn't even read his? His homework took him like this much space. And let's pull those tree huggers. He's afraid to waste another piece of paper. Questions on those levels? Katie's going to make sure she goes back over that stuff, because Malachi's probably going to tell her, hey, it's not quite, it's not hard, but it's not easy either. Maybe get the notes off somebody. All right, what we're going to cover today, experimental design. You can write that down. That'll be the title of your notes for the day, experimental design. See that title, what should you think of?
Experiments.
You're designing an experiment. Designing an experiment. What we're going to cover, how to design a statistical study, data collection techniques, different ways to collect data, how to design an experiment, and different sampling techniques. It used to be, I'm thinking in algebra, in the algebra class, one of the first sections in algebra was, what was it? Maybe it was math 2 or 3 or something. I don't know. One of the classes I used to teach had different sampling things, random sample, cluster sample, so on and so on. That's sort of the same thing here. Guidelines for, get rid of this. Guidelines for designing a statistical study. Number 1, identify the variables. If you wanted to write this down, this is how you do this. I wouldn't write the whole sentence that I have for each one of these, all right? Identify the variables, might be all I write. Identify what you're looking at, what you want to find, what you want to deal with. If I'm trying to do some kind of study on concussions in sports, right? then when we identify that, well, that's gonna affect the population we study. So if I wanna deal with concussions in sports, I probably don't wanna go down and, I'm not gonna go down and talk to the band people and survey them or use them as my population. Develop a detailed plan for collecting the data. Decide how you're going to collect the data. You're going to do a survey. You're going to do an experiment. Are you going to do just something where you watch to figure something out? Just like I was saying up here, when you pick that, make sure if you're going to do some kind of sample because you can't get the whole population, make sure your sample is a good representative of the entire population that you're wanting to look at. If we wanted to talk about concussions in sports, would it be a good sample if I just went and talked to the football team? No, that's probably the worst place to go, right? Because that's a major contact sport, and there's probably going to be more concussions in it. So we want to talk to all the different sports: volleyball, cross country, golf, soccer, everybody, not just one. You want to make sure it represents the whole population that you're wanting to look at. Now, if you're just wanting to talk about how concussions affect football, then you probably don't want to talk to the girls' soccer team, because that doesn't have anything to do with it. Collect the data. So somehow you're going to collect that data. This morning when you walked in, I collected this data. Now, the bad thing with this data is, this is what's going to happen to it. So it wasn't like the whole purpose of doing it wasn't so that I could see if Sydney would lie to me about never stealing something or anything like that. It was just to see, to let you know what's going to affect these different studies. So decide how you're going to collect the data. You're going to do a survey, you're going to do some kind of experiment, or you're going to do something where you're just sitting watching. Describe the data. Once you collect all your data, look at it, say, okay, 10% of all people who play high school football get a concussion. 7% of all people who play all high school sports end up with a concussion, so on, so on, so on. Malachi's looking at me like, if it was 10% for football, how could it go down for all sports? Why would it go down for all sports? Because you got a bigger number, right? Interpret the data. Make decisions about population using inferential statistics. What's it mean, inferential statistics again? Making an inference why this happened. All right? Making some kind of inference, making some kind of judgment about why something occurs. Now this is a big part of statistics, is those inferences. But again, you've got to be very, very wary about that last part of what you do in a study. Because just because I make an inference about something, does that mean that's the way it's going to be? Mr. Boggs is now in this class, and I'm making an inference in my head that I probably will not see him about 60% of the time. Because he had Mr. Alexander last year, maybe, first block. And I know I didn't see him walk in there more than half the time this early in the morning. So I made that inference in my head. Now, could I completely and totally be wrong? Yeah, but what I did was I did a little study from what I noticed last year, and now I'm thinking, yeah, he's probably not going to show up very often first block. So those are inferences, right? You make an inference, you make some decision about the information that you gathered. And again, when we get to those inferences, it could be completely and totally biased or wrong because maybe our population, our sample for our population wasn't good. Again, going back to the presidential thing, I think part of the thing is when they were doing the presidential election and they're doing the surveys now, I can't say for sure because I'm not really a Republican or a Democrat, but I think Democratic people who belong to the Democratic Party are more likely to answer surveys and stuff like that. I would probably, if I had to stick myself in one of the two categories, I'd probably say I'm more Republican. And my guess is if Republicans are sort of like me, I get a phone call and it says, yeah, we'd like to give you a little short survey about President Trump and how things are going. I hang it up. All right? Now there's probably, I think Democrats are more likely to want to tell their point. When I taught at Dayton Jefferson, there was a math teacher, and he was a big Democrat. And I'd walk into his classroom, and I taught there for about 10 years, and there was at least 5 times I walked into his classroom, and he'd be on his cell phone. And I'd wait for him to get done, and he'd say, sorry, I had to call my congressman. He was calling his congressman at Columbus to tell his opinions. And I thought, yeah, you're the kind of person I bet that the secretary thinks, oh my God, not this guy again.
Yeah, same week.
I would never ever think about calling Columbus and talking to the congressman. And I get stuff on my email all the time, and a lot of the education association people are Democrats, and they send me stuff. Call your congressman about this. Send your congressman an email about this. Do this, and they want you to. And I just never have done any of that.
I didn't do it.
You what?
Oh, you missed this.
That's not what I wanted to do. Methods to collect data. Ways to get the data. The first one. Observational study. A lot of this stuff, just common sense if you think about what the words are. Observational. If you're doing an observational study, then you're just observing. You're just seeing what happens. That's one way to collect data. What was that woman's name? Jane somebody went out and lived with the apes for so many months or whatever. You guys remember that? That's a few years ago. No, not that Jane. Her name was like Jane Woodall or something. I don't know. I guess that's before you guys' time. You went. But anyway, this woman went. I don't even know where she went. Wherever there's apes at. And she observed them. All right, and after a while, the apes got used to her, and she was actually could interact with them also. but she was doing an observational study where she's just watching what happens. Other things for observational studies, meteorology, all the weather. When you see a weatherman say, oh yeah, there's a 50% chance of rain today. All they've done is they've collected data over the last 100 years, 150, however many years they actually have the data for, and they say when stuff is, or when the different, I don't know enough about meteorology to tell you, when conditions are this way, there's a 50% chance that it's going to rain. So they've looked at 100 days like today, and out of that 100 days, just like today, 50 of those days it rained. So that's where they're getting that 50% chance, right? And everybody always hates, oh, the meteorologists are always wrong. No, they're right every single time. Because if they say there's an 80% chance that it's going to rain today, there's still a 20% chance that it's not going to rain. So just because they said it's an 80% chance, that doesn't mean they're wrong, because they're saying it's 20% chance it's not going to rain. Observational studies. An experiment. Doing an experiment. Some of you will probably go take advantage of some of this stuff I hear on the radio every day, driving back and forth, where they're looking for subjects to study taking some drug, all right, and they're going to study it, and they pay you for it. You go for like a weekend or a week or whatever, depending on how long the study is, and they give you some kind of drug or whatever it is, whatever they're testing. Maybe it's not even a drug. Maybe it's a pillow, and you go in and you sleep on their bed each night, and they hook electrodes or whatever up to you to see how well you sleep with that pillow, how well you sleep with a different pillow. Might be some kind of experiment. That's an experiment. Now notice it says a treatment is applied to part of a population. Well, there's some other things that we're going to talk about later on today. If next class I come in and I say, all right, we believe it's a proven, or we believe that it's a fact that if you drink chocolate milk in the morning, you learn better throughout the day. So I start giving every one of you chocolate milk in the morning. Am I really going to be able to prove a point by giving every one of you chocolate milk? No, because I don't have anything to base it against. I don't know Dalton back there. He's doing real well, and I'm saying, yeah, it's because of the chocolate milk. No, maybe he was going to do well without the chocolate milk. So a lot of times what you'll have is I'll come in and I'll say, this is our thoughts about chocolate milk, and I'll pass out chocolate milk to everybody, but some of you I'll give some kind of off thing that's not really chocolate milk. It's hard to do, but so it would be more. It would be more if we could use pills. All right, if I was to give you some kind of pill every morning, this could never ever happen in here. So I'm recording this. Don't be going home telling your folks, listen to this. Ebersol's going to give us some kind of pill. If I could give you some kind of pill, and I'm telling you this pill will help you focus and help you learn better. All right. If I gave all of you the same pill, is that going to show anything? No. So what I'd have to do is give some of you the pill, and others would get something different. But they would think they were still getting the pill. And that way, if I'm giving Katie the pill that does nothing, and she's oh yeah, this pill helps me a whole bunch, because she's got it in her head there that, hey, Eversole said that this pill was going to work here. And that's what it is. And I wasn't gonna mention that because that's a word that we're gonna see here in a few minutes. So it's called a placebo, all right? A placebo is something that you get and you think it's gonna do something, but it's really nothing. Not gazebo, placebo. We'll talk more about that here in a few minutes. Simulation. Use of mathematical or physical model to reproduce the conditions of a situation or process. So you just do some kind of simulation. Here lately, not lately, last year it was big. There was simulations on like ESPN and stuff where they were simulating Golden State playing the 1990 Bulls, and they were trying to show a simulation. Then a couple years before that, there was a simulation where they, on the ESPN, where they had a big thing where Rocky Marciano fought Larry Holmes to see who was the better boxing champion. They do stuff like that. So that's a simulation. With computers, you see a lot of simulated stuff now. Just to see, hey, how is this going to work? Next one, a survey. This is probably the one that gets used the most, just because it's easy. I go downstairs, I run off copies, and I hand you a survey. And I take the information from that and try to figure out whatever it is that we're looking at. Along with this, a census. Census is a way to try to measure the entire population. So when you're doing a survey, if you're trying to get the entire population, you're doing a census. When you're just trying to do part of the population, you're doing a sample. So census or sampling. Remember, census goes with population, sampling, just part of the population. With an observational study, and I'm just going to run through this real quick. A researcher observes and measures characteristics. So you're just looking at it, you're writing down stuff, you're observing whatever. Maybe I stand out in the hallway and I stand there and I keep track of who's wearing a blue shirt, who's wearing a red shirt, who's wearing a black shirt, different colors of shirts. Why I would do that, I have no idea. But researchers observed and recorded the mouthing behavior of non-food objects of children up to 3 years old. If you ever see, if you have any younger siblings or nieces or nephews or whatever, and they're less than 3 years old, you hand them something, what's the first thing they do with it? Stick it in their mouth, right? They stick it in their mouth. So some researchers did an observational study about why is that, you know, when do they not stick something in their mouth maybe? What would cause them not to want to stick it in their mouth, and so on and so on. Experiment, a treatment is applied to part of the population. So you have a control group. The control group doesn't get any treatment. The bad thing with that, if I'm passing out these pills telling you that they're going to help you focus and learn better, and I just say, Malachi, you don't get anything, well, then that sort of ruins the study. All right? So you have to give Malachi something, and we talked about that a second ago. Even though he's not getting whatever the treatment is, he's getting something, so he thinks he's getting the treatment. And then we can compare that. And that fake treatment is called a placebo. Placebo. And what Ms. Clark said earlier, the placebo effect is when I give you something knowing that it's absolutely nothing, and I tell you, this is going to help you get better, and you get better. So I didn't really give you anything that would have helped you, but just the idea that you thought you were going to get better somehow caused it to work. An experiment was performed in which diabetics took cinnamon extract daily while a control group took none. After 40 days, the diabetics who had the cinnamon reduced their risk of heart disease, while the control group experienced no change. Some of this stuff, like this experiment here, seems sort of cold, doesn't it? If I think this is actually going to help you, and I say, okay, Malachi, you get the cinnamon extract, Katie, you get none, and we're going to see. And Malachi is all of a sudden doing better. Now I sort of just put it to poor Katie over here because she's not doing better. But we've already wasted 40 days. Maybe by that time it's too late. Simulation. Uses a mathematical or physical model to reproduce the conditions, situations of a process. Often involves the use of computers. If you have a TI-83 or 84 calculator, please make sure you get a TI-83 or 84 calculator and start bringing it. You will not be able to do this stuff in a couple of chapters without one. If you don't want to spend the money, then borrow one off of somebody. I'm not sure if mine has it on here. I think it does, but I can't remember. If we wanted to do a simulation of picking numbers at random, on my calculator here, if I go to probability, it says RAND, it's got a random number generator. So it just gave me the random number of 0.5, 1, 4, 7, so on, so on, so on. Some random out of the blue number. Now, we probably wouldn't want that number. We'd probably like do 1 through 100 or something and just do the whole number. So we could set it up and it would pick numbers at random 1 through 100. All right? And it would pick, I have to look back how to do it. You put stuff in parentheses. Let's say you wanted to pick 7 numbers. You were just picking out of a hat all the numbers 1 through 100 and you wanted to pick 7. It would show you 50. 12, 13, 17, 92, so on and so on. So random numbers. A lot of times computers are used when you're doing some kind of simulation. Automobile manufacturers use simulations with dummies to study the effects of crashes on humans. You see that on commercials all the time where they're showing the cars crashing and how well their cars protect the dummy and other cars don't. They're doing simulations. Without a simulation, it wouldn't be a very good thing. They probably couldn't pay Dalton enough to say, hey, we're going to set you in this car and run you into this brick wall at 50 miles an hour and see if it hurts you or not. Right? So they have to use simulations. Survey and investigation of one or more characteristics of population, commonly done by interview, mail, telephone, so on. The sheet that I handed out to you earlier, that's all a survey is. Survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. So you just go out, when you do a survey like this, what's going to be their population? On this survey, who would be their population? Where are they picking from? Female physicians. You're probably not going to ask Michael, right? All right, just some terms. Bias. Bias is just when some certain outcome is favored. For some reason, for whatever reason, it's favored. Could be something where whoever's doing the study wants it to be that way to make their study look good, or it could be something that just happens. When I asked you on that paper if you were taking Providence stats, and then I could say, yeah, 100% of all National Trail students take Providence stats, I did that on purpose. So I was making it the study biased. A confounding variable. A confounding variable, you ever heard your grandpa say confounded? Well, that's what that means. Confounding, never heard that. A confounding variable. You can't tell what factors cause the outcome. So something happens, and there was some kind of variable in there that just caused it to not come out the way you thought it was going to. Or caused it not to come out well. Not to come out and to give you good information. Say we were going to take a test in here next class, and all of a sudden Mr. McKnight comes up and says, hey, when you take your next class or test in this class, I want to see the scores. And so we take our test. Maybe it's like today, we take the test on a Monday, and it happened over the weekend, something not good happened. Well, that could be considered a confounding variable, because maybe that caused Miss Clark to not study like she normally would have, or Sydney to not do as well because her mind's not in the right spot. Placebo effect. We talked about that. Placebo effect, subject reacts favorably to a placebo. So you're getting a placebo. Remember, placebo is something that really, a lot of times, if it's a drug, some kind of drug that they're testing, they'll use sugar cubes or sugar pills. And they just give you that sugar pill, and you take it, and you think you're getting some kind of actual medicine, but it's not. The Hawthorne effects. Subjects change behavior because they're in an experiment. So if I'm doing some kind of experiment on 10 normal people, and they know they're in that experiment, maybe they don't quite act like they normally would. It's called the Hawthorne effect. A blind experiment. Subjects do not know if they're placebo or treatment. Doesn't do any good to give somebody a placebo and somebody else the treatment if you tell them, here, Michael, this is the actual treatment. Here, Jacob, this is a placebo. Here, Dalton, this is a placebo. Well, then it's not going to do any good. So you do a blind experiment. And the best experiment, something like that, is a double blind. Because if I made this medicine that's going to cure stupidity, and I'm giving it to Malachi, and I'm giving it to Katie, and I'm giving it to Bryce, I'm giving it to all you guys, I want the medicine to work, because if it works, I'm going to make a bunch of money, right? So if I know that Katie got the placebo and Malachi got the actual treatment, then I'm over here going, yeah, Malachi, make sure you, and I'm trying to get him to learn more and more and more to get rid of that stupidity, right? A double blind is when the person doing the experiment doesn't have any idea who got what, who got the placebo, who got the actual treatment. That way I can affect what's actually happening. Because if I can affect what is actually happening, especially with some kind of drug, I'm going to try to affect it, right? Because those people that come up with a new treatment for cancer, or new treatment for diabetes, new treatment for whatever it is, they make bunches of money. I mean, that's the big, big money. Replication, redoing an experiment under the same conditions. You might do a replication, you might do an experiment a second time, just to see if it's going to come out the same way as it did before. That way you can tell, hey, this wasn't just a one-time fluke. This didn't work out this way just because some confounding variable got in there and caused it to come out that way. Lots of different things for experimental design. Different ways of controlling the outcomes. Randomization. Randomization is randomly assigning subjects to different treatment groups. There's lots of different ways to do it. Sample size, number of subjects in an experiment. Not real difficult. I mean, sample size, you can probably sort of understand that. Randomization, nothing really hard there. So, census we talked about. Census is the entire population. Sampling is just part of the population. Sampling error. Sampling error, very important, and we'll talk about sampling error a lot on down later on in the year, like chapter 7, chapter 8. There's ways you can figure sampling error. Maybe on some poll you heard on TV this morning, it said that 12% of all Americans think whatever. And then it'll say plus or minus 3%. All right, and that's the sampling error. So in other words, they're saying, well, this probably isn't exactly 12%, but we can pretty sure say it's between 15 and 9%, somewhere in that range. That's sampling error. There's gonna be some kind of error, because if I just take a sample, it's not necessarily gonna give me the good look at the entire population. And when you have that sampling error, there's a way to figure it out, and again, we'll talk about that in like chapter 7, chapter 8. There's a way to figure out exactly how good your sample is, how much error you have on that sample. Some samples, it might say 12%, and I know last year during the election, I seen something where it said Hillary Clinton in Virginia had a like 15% lead on Donald Trump. And then out to the side it said error of plus or minus 16%. Well, that's a whole bunch of error. So what that tells me is they did a real small sample, and they're saying that Hillary's up by 15 points, when if we subtract 16, she could actually be down by 1 point in that certain state. Sampling techniques, these are important here. Different sampling techniques. Random sample and simple random sample. There's going to be about 4 or 5 of these sampling techniques. A random sample. Every member in the population has an equal chance of being selected. You guys don't see them anymore. But when they tried to do random samples in the past, they used phone books. And they would just go through the phone book and pick at random. And that was okay, but it still didn't give everybody the equal chance, because some people didn't have phones. And that's like unheard of now, right? That you don't have a phone. And then a simple random. Every possible sample of the same size has the same chance of being selected. So I picked, it looks like they got, what, 5 X's in there? Those 5 X's have the same chances of getting picked as those 5 X's right there. And these 5 right here have the same chance of getting picked. And these 5 have the same chance of getting picked. There's no reason that one group has a better chance of getting picked than another. So random samples and simple random sample. Basically the same thing here. When you're doing a random sample, you're doing something where everybody's got the same opportunity of being picked for whatever it is that we're doing. I just talked about this. Go to probability on the calculator. Go to number 5, random integer. It would kick out some numbers. We put in this 1, 5 to 504, and it would kick out 4 numbers in between 1 and 500 just randomly. Stratified sample. Stratified sample has members from each group segment of the population. It ensures each segment is represented. So if we have freshmen, sophomores, juniors, juniors, seniors, we have all of those different groups. I can't come in here, if we're going to do a stratified sample, I can't come in here and do a survey. All right? Because I would only be getting the upperclassmen. I wouldn't be getting a sample from everywhere. So a stratified sample is when I take a couple of people from here, a couple of people from here, a couple of people from here, a couple of people from there. You take some from every part or every different group. Same thing with male or female. If I'm gonna do some kind of observational study, I can't just look at the males if I want it to include everybody. You have to look at male and female. You have to take some from this group and a few from that group. So that's a stratified sample. You take a few from every group. And it just did the same thing I did there, circle mention. A cluster sample. Cluster sample, another way. Cluster sample. You have all the members in a little group somewhere. Has all members from randomly selected segments of the population. This is used when the population falls into naturally occurring subgroups. Cluster, our school is a perfect example of cluster. All right? Maybe I go out in the hallway right now and I'm going to do a survey, and I go over to Mr. Slam's room and I give them the survey. And then I go down the hallway and I go to Mrs. A's room and give them the survey. I'm doing clusters. They're all in that certain little area there. They're all clustered together for whatever reason. You got to be careful with clusters, because a lot of times with clusters, and I think a cluster sampling is what a lot of these political samples are, because they go somewhere and they say, okay, who are you supporting? Well, if you're at the Democratic convention, you know they're probably supporting the Democratic person. So cluster samples, just when you're surveying or observing or whatever, a little cluster. So if this is my, this is Clarksville, and it's divided up into little sections, I just pick certain little sections, and I go to those sections and I survey the people in those sections. And then I say, okay, that's a good representation of the entire city of Clarksville. Very good. Systematic. Systematic's probably the easiest kind to figure out. Systematic, there has to be some kind of number. When you write down something about systematic, write down number. If I'm going to do a systematic sampling, I'm going to stand out in the hallway and I'm going to pick every 10th person that walks by, every 8th person that walks by. Systematic always will have something like that. Every 4th person that walks by. So just selecting them at regular intervals. Amazed at that. So if I have all those, I don't know, they look like bananas, I guess. I pick that one, then I pick that one, then I pick that one, pick every 4th one. That's systematic. Convenience sample. It's what I'll do a lot because I'm lazy. Gave you guys a survey this morning that was convenient for me. I'm standing out there and I'll just hand them out to you as you're walking in. Convenience sample consists of only the available members, who's right there and easy for me to get to. Convenient sample is not always the best thing. Just because it's convenient doesn't mean it's going to give you a good look at your entire population. I go down to the cafeteria today at lunch and I pick a table because it's closest to the door and I don't have to walk very far to get to them. And I ask them, what movies did you go see this weekend? And I write those down. Is that going to be good to show that that's the best movies that are out there? Probably not, because if I'm looking at just that one table, all those people at that one table probably have the same likes and dislikes. Otherwise, they wouldn't be sitting together. So that's a convenience sample. You're doing a study to determine, stop. You're doing a study to determine the number of years education which each teacher at college has. Identify the sampling technique used if you select the sample listed. You randomly select 2 different departments and survey each teacher in those departments. What were the samples? Give me the sample names that we just had. First one was random, right? Then what? Cluster. Systematic. Convenience. Did we miss one? Simple random. That's sort of convenience. I don't know if I spelled that right or not. Random and simple random would put those together. Was there only 4 of them? I thought there was 5. Stratify. So we look at this. You randomly select 2 different departments and survey the teachers in those departments. Which one of those did we use? Think it's random? Stratified? I don't know. Let's find out here in a minute. We'll say random or stratified. You select only teachers you currently have this semester. Which one of those do you think we used? Convenience. It'd be convenient for us. You divide the teachers up according to their departments and then choose and survey some teachers in each department. Systematic. Remember, with systematic, what are you going to think of as soon as you hear systematic? Every 5th, something like that. Is that what we're doing there? Convenience? I don't know, let's find out. See how many of them we got right. I can make it go. First one, cluster. Who said that? So that first one was a cluster. All right, with the cluster, what are we doing? We're taking all members, but then we're picking this group, this group, this group, this group, right? And doing those. Second one, we said convenience. Let's see. Got that one right. So convenience, because it was easy for us, right? They were readily available for us. Last one. We want to change on the last one before we
Probably stratified or whatever.
think it's stratified. Stratified sample, because the teachers are divided by their departments. So you got all these departments, and then you just take some from this department, some from this department. Remember when we had freshmen, sophomores, juniors, and seniors? We took a couple of people from here, a couple from here, a couple from here, a couple from here. Stratified. Open up your books to page 23. Page 23. Let's skip 1 through 4. Let's jump to the true and false since we don't have a whole lot of time. In exercises 5 through 10, determine whether the statement is true or false. And we're just going to tell whether it's true or false and rewriting it. Don't ever worry about that. If it's a true or false, just answer true or false on any of the homeworks that we do. I'll tell you the next time what would make it true or whatever. Number 5, in a randomized block design, subjects with similar characteristics are divided into blocks, and then within each block randomly assigned two treatment groups. True or false? That's it, true. We didn't talk a whole lot about the randomized block. Right, that is true. Number 6, a double-blind experiment is used to increase the placebo effect. True or false? That's true. Use a double-blind so that everybody thinks that they're getting good treatment, and that would increase the placebo effect. Now, does that mean that's why we do the double-blind? No, but it would increase it. Number 7, using a systematic sample guarantees that members of each group within a population will be sampled. False. Just because I pick somebody every 5th person, does that mean that I'm going to get the same number of freshmen, sophomores, juniors, and seniors? No. We'd have to use stratified to do that. Number 8, a census is a count part of a population. False. Census goes along with the whole population, right? Sample goes with part. Number 9, method for selecting a stratified sample is to order a population in some way and then select members of the population at regular intervals. False. What did they show there? Systematic. All right. Stratified is where we have little groups, and then we pick random groups to put all together. What are we on, 10? To select a cluster sample, divide a population into groups, and then select all of the members in at least one of the groups. So that one is what? That's how we do a cluster. All right? Stratified is sort of close to that, isn't it? But stratified, I'm sorry, I think I said that wrong. Stratified is where we take a couple of members from each of those. Cluster is where we take this whole group, this whole group, this whole group. I said that wrong a second ago. Deciding on the method of data collection. What were our methods of data collection? Different ways that we could collect data. Experiment, simulation, survey. What was the first one? Observation. Is that all there was 4 of them? So we're deciding what would be best for this each thing. A study of the health of 168 kidney transplant patients at a hospital. What would be best for that? Observation, probably, right? Or what else could we use? I don't know that we can use an experiment because that goes back to, that's pretty morbid.
Survey?
Maybe a survey or a census, right? We could, after they get their kidney transplant, we can't say, okay, yeah, you don't get a transplant today. But after they get it, we could survey and see how they're doing. So survey would also work there. A study of motorcycle helmet usage in a city without a helmet law. Experiment, maybe? How would we do an experiment with that? What would we do? Would we do an experiment? Observe it? Observation? Because we just look at it, okay, yeah, that person's wearing a helmet, that person's not. So maybe observation. 13, a study of the effect of the human digestive system on potato chips made with a fat substitution. There we could do an experiment probably, right? Probably wouldn't have too hard a time getting Malachi to eat some potato chips and looking at what they do to his body.
I guess you could look at.
Now, just because we say experiment on that, does that mean it's the only way? No, there's probably other things that we could set up. 15, a study of how fast a virus would spread in a metropolitan area. Probably a simulation. Why not an experiment there? Yeah, we don't want to, I'm not going to go to New Paris and say, you know what, we got this virus. I'm going to throw it out here on the street. Let's see if everybody gets sick. Probably not a good thing.
There's no homework. Come on.
That's your assignment.